So, have you ever had an electrical problem with your issue that seemed really simple, but you have no idea where to even start with the diagnosis? Well, today I'm going to go over a case study of a vehicle that came through our shop at the school where I teach with a seemingly fairly simple issue, how we went about diagnosing it, and how the root cause ended up being something that's more common than you may think, and how it affected the vehicle. So grab a pen and paper, get ready to take notes because here we go. So before I get into what the vehicle is and what the problem is, I want to take the time to say thank you all very much for your support of the channel. For only having 2 videos published so far, to have the subscriptions and the views and the comments that I've had is just mind-blowing to me, and I appreciate it very, very much. I do what I do in my day-to-day job because I love teaching others. I love to see that aha moment when students just get the concept I'm teaching, and that's the reward for me. And also seeing the students become successful technicians, and we have many of those. So just wanted to say a huge thank you to that. So please like and subscribe to the channel, and I will keep shooting videos out when I can. I'm an extremely busy person. So what we have, 2001 Chevrolet Silverado, fellow instructor, not in our program, in another part of the college, says that the HVAC, heating, ventilation, air conditioning blower motor is not working at all. Okay, that's the customer's concern. What we're going to find is something kind of mind-blowing, but very common on these vehicles. I've seen this a handful of times, but it was a really good learning lesson for my students. And if you're an entry-level tech, or maybe, I don't know, you're new to this profession, maybe you haven't seen this issue yet, and this will help you. So I wanted to teach how to use wiring schematics to help diagnose the issues. So that's what we're going to do. We're going to dive in here, and we're going to start with the blower motor wiring diagram. So let me get that pulled up. There we go. Okay. This again, it's a little more complicated than the horn schematic that I did on my wiring schematics video, but it's still not super complicated. So this is a good one to go with. So again, customer's concern, blower motor not working. Let's go run over really quick how this works. So I'm going to hold my whiteboard, my pad, just so it's easier for me to see. So over on the left-hand side, we've got this, we got the fuse block, which is the instrument panel fuse block, and heater AC fuse. Okay. So I'm just going to trace the path down through each one of the legs and explain that. So we're going to come through the heater AC fuse, and then we're going to go over to the low channel. Okay. Or the low setting, not the low channel, the low setting. Follow it down, and we're going to go through this squiggly thing right here. So any idea what these little sawtooth looking things are? Y'all remember what those are? Okay, those are resistors. So we're going to go through, let's just follow the path. We're going to go through 1, come up, go back over to number 2, come back up, go back over, number 3, come back up, go back down, 4. I'm going to go over, and this is the blower motor relay, which is built into the blower resistor assembly. And the switch side, the left-hand side of the blower motor relay, is naturally closed to where the blower gets power from the resistors. So if we have it in the low setting, the current's going to flow through 1 resistor, 2 resistor, 3 resistor, 4 resistors, eating a lot of our voltage up. And the blower motor will blow on low because we've eaten a lot of the voltage up. And then on the bottom side is going to go to ground, and we have low speed. Okay, so that's how low speed is going to work. back all my annotations out really quick. There we go. Do it the fast way. Okay. So for medium 1, again, we're going to start at the fuse. Now we're going to turn our switch here. We're going up a blower speed. Voltage is going to come down here. 1 resistor, up, down, 2 resistors, up, down, 3 resistors through our closed relay, closed to the blower side. Through the blower, blower's grounded. Blower will blow a little bit faster because this time we're only going through 3 resistors. So a little more voltage is available to blow for our blower to use to blow a little bit faster. Okay. Then for medium 2, come down almost straight down. We're going to go through 1 resistor, up, down, 2 resistor, over, through the relay. Blower blows a little bit faster. You're kind of getting it, right? And then on medium 4, we're only going through 1 resistor, this one right here. So the blower is going to blow a little bit faster. So what changes next for high speed is we want full voltage going to our blower on high speed. We can shoot everything to it. And GM does something kind of interesting here. So on high speed, we're going to come through our heater AC fuse like we've been doing over to the high switch side. So this truck does not have auto AC. It's not a digital display. You have to turn the knob to each blower speed. You have to select your heat or cold, not to a temperature, but just turn the knob. So we're going to follow our voltage down. We do not go through a resistor this time. And what's wild is we're going to go straight to the coil side. We're going to go right to the right-hand side of this blower motor relay. So if you remember from my relay lesson, and if you didn't watch it, go back and watch it. It's good stuff. So we're going to go through the coil side of the relay, which is grounded at all times. We're going to energize that coil, which is an electromagnet. That electromagnet is then going to flip this switch that's on the left-hand side over here. So we're going to toggle it over. And now the blower is actually getting its full power from this fuse, which is FRT, front HVAC fuse. It's going to come down through here, shoot juice straight to the blower motor, and it's going to be wide open speed. Okay. So I wanted you to understand how it works. And as a technician, even as a DIYer, if you don't understand how a system operates, then it's almost impossible to be able to diagnose it. So I spent the last several minutes just helping you understand how it works. Okay. Now let's start with some diagnosing. Okay. So the customer's concern is we're not getting anything at all. So what could our possibilities be? What are some things that could make the blower not blow at all? Let's go over these. Okay. So the first one is it could be a bad blower motor, right? Very big possibility. Another one is, so I'll circle these. Blower motor is one. Okay. Another one, this ground could be bad. If we had a bad ground, then our blower motor may not work. So I'll give you a tip on this. If you suspect you have a bad ground, go right here. This says ground distribution schematics. What that's telling us is that ground is used for something other than just that blower motor. So if most manufacturers, that would be a hyperlink. You could click that and it will show what else goes to that ground. Now, if the other components are also not working, then I'm sus. G200 is sus right now, if that's the case. But if everything else is working, I can assume the G200 is okay. Although the wire could be cut up here, we still could have a bad ground wire. Another possibility and this is very common on these trucks, is that the blower motor resistor connectors, where the terminal pins go into the connector and they connect to the resistor, those are prone to what's called micro arcing. Micro arcing is, if you think about welding, like stick welding, you know how it sparks and stuff, very on a very microscopic level. And that creates resistance over time. Resistance equals heat. Those connectors will melt, the resistor will melt, and it stops because of that. Okay. And then the other issue is we could have a blower motor switch bad, and we could have fuses bad. Okay. What are the chances of having 2 blown fuses? I will say from my experience, it's highly unusual to have 2 blown fuses. Very highly unusual. So my students, because they're students, and hey, I didn't mean to chuckle, or I'm not making light of that, because a DIYer may do the same thing. So you look at the wiring diagram and you're like, oh, here's the fuse I need to look at, because it goes directly to the blower motor relay, and I'm going to check this fuse, and guess what? That fuse was good and it was getting power. Okay. So at that point, my students assumed that the fuse, that everything was getting power. Okay. So they went down to the blower motor resistor, and they had power on G, but they were not getting power on any of the other legs at any other speed. And that's when they went up and they realized, oh, there's another fuse up here too. Maybe we should check that fuse. So let me show you something. And I covered this in my wire schematics basics video. And it's kind of hard to see, at least on my end it is. On the left fuse right here, it gives you the condition that fuse will have power. So for this fuse that's in the instrument panel fuse block, its condition that it will have power is the ignition switch has to be in the run condition. So it says hot in run. So if the ignition switch is off, that fuse won't have power. It has to be in the run position. Okay. Now the fuse on the right-hand side that's in the underhood fuse block says hot at all times. That means no matter what, unless the battery is dead, that fuse is going to have power. Okay. So what my students discovered was that the left side fuse did not have power at any time. Right side fuse did have power all the time, just like it's supposed to. But the left side fuse, this one right here, even if the key was in the run position, in fact, if the key was in any position, we didn't have power at that fuse. So do I have a bad fuse? Most mini fuses, if you look at the very top of the fuse, I'm going to draw a really crude because I'm not an artist. What size was that fuse? Looks like a 20 amp. Yeah, it looks like a 20 amp. Most of the smaller fuses, if you look straight down from the top, you'll see the 20, but you'll also see a little piece of metal, which is the top part of the leg that sticks down into the fuse block. You'll see a little piece of metal here, little piece of metal here. So what you do, you get you a test light. I'm going to draw a bulb. You go to ground. You touch the other end, the pointy end of the test light to one of those. If it lights up, yeehaw, that's good. Then we're going to go over to the other side. If it lights up, our fuse is good. If we get power on both sides of that fuse, then the fuse is good. If we only get power on one side of the fuse is bad. Okay, the fuse is blown. So that's a really quick and easy way to test these fuses, is just use test light, touch each of the top side of the fuses. If it lights up on both sides when it's in the right condition, remember it's got to be, the ignition switch had to be in run. If it lights up on both sides of the fuse is good. If it only lights up on one side, the fuse is bad. If it doesn't light up at all, uh-oh. Okay, in this case, we had no lights. What is that telling us? Okay, so I relate this to my students like this. If I'm at home and I am trying to wash my hands in the sink and no water comes out of my faucet, I could have a bad faucet, right? But I know my faucet's good. Okay, so where am I going to look for the source of my issue? I'm going to look to see where the source of the water is, right? My main line coming into my house. I'm going to check my other faucets, so you can check some other fuses, right? I'm going to check my other faucets. If none of my other faucets that are related are getting water, then I'm going to look upstream. What is the source of my water? That could be my problem. So the same thing here. Okay. This does not connect directly to our battery. Okay. It connects to something. We don't know that yet, but it's not the battery. So we need to find out. So if the fuse is not getting power, what is the source of that fuse? Okay. That's going to be what we need to figure out next. So also, get in the habit of, when you have an electrical problem, sometimes customers may not use a feature that their vehicle has, and it can be a huge clue to you to test everything else, see what else may or may not work. Because that can help you tremendously in diagnosing what may be wrong with the vehicle. So in our testing, we also figured out that I'm getting ahead of myself here. Hang on a minute. The radio wasn't working. The door locks also were not working. The power door locks weren't working. Excuse me. The power windows, back up. Okay. The power windows and door locks, neither one were working. So I got in the habit when I was a tech of going ahead and checking all the electrical stuff, especially if I didn't have power on one fuse, just to see if something else, if multiple items were, not working. So summertime, blower's not working. We test everything else, and the blower motor and the door, not the blower motor, the power windows and the door locks also are not working. So I've got that schematic pulled up for us. This one gets a little more confusing. I'm not going to get into all the details, but we can see we got a ground down here. Okay, oh, wait a minute. What ground is that? Ground 200. What? What else shared ground 200? Our blower motor. Could that be sus? We'll see. All right, and then we've got ground 203 down here also. So that's our ground end of things. And then as far as power, we've got this, which says B. Is that a B? And then A right here. And what that's telling us is, hey, on actual wiring diagrams, you can click it. It's a hyperlink. It will take you to the other part of the schematic, which I'm about to do. Okay, so we can suspect our ground, but is it a ground issue? No. How do we know? Well, we don't know 100% sure it's not the ground, but we do know it's something. And what is it that we do know right now? We do know that we're not getting power to that one fuse to our blower motor. So let's see where these get their power and see if maybe there's something in common. We may circle back to the ground because it is a shared ground. That could be our issue. So let's go to the next diagram over. And now we have, there's our B and our A from the previous diagram. So let's follow it back up. We'll go with the B. Follow it up. Here's our power window circuit breaker. Follow it back. There is a wrap relay. A wrap relay? Bill, what the heck is that? So it's not a relay that wraps. Wrap stands for retained accessory power. You know how like you shut your vehicle off, you're listening to the radio and the radio still plays for like 10 minutes or until you open your door? That's thanks to the wrap relay. So retained accessory power. All right. So wrap relay is going to go up. We'll just keep on following it up to the ignition switch. And look at there. It goes to the run part of the ignition switch. So when it says that our fuse over here is hot in run, it comes directly from the ignition switch, okay? The electrical part of the ignition switch. All right. So, could we have a bad ignition B, this fuse right here? Could it be bad? It's very possible it could be bad. Easy test to go to it because it says it is hot at all times. So we go to the instrument panel fuse block because it just says fuse block. It doesn't say under hood. So we go to the IP fuse block. We check and it does have power on both sides of the fuse. So what's that telling us? It's telling us our fuse is good. So now we can kind of suss out something else, right? What's our other, what's the item here that we can really be suspect of now? Okay. I'm going to start suspecting our ignition switch at this point. Okay. We could go to the fuse block and we could, check for power here to see, but I'm telling you, pulling these fuse blocks out and getting behind them to check for power is a pain in the butt. I'm a work smarter, not harder type person. So what I'm going to tell you to do is let's look at the ignition switch wiring diagram. Okay. The other thing that wasn't working is the radio. The radio wasn't working either. If you look at this diagram, you'll see the radio fuse is right here. So it's also powered from the run tab on the ignition switch, or the run contact in the ignition switch. So that's this fuse right here, radio fuse. Okay. I just threw that in there just to show you that. But let's take a look. This is the ignition switch wiring diagram. Okay. So let's look at the run part of the ignition switch. Here's our ignition switch, far right at the top. Run is right here. Follow it down, and it's going to control the brake fuse, the cruise fuse, heater AC fuse, radio fuse, HVAC 1 fuse, and ignition 3 fuse. Dang. And then on the other side, this run right here, so this 2 run contacts is going to feed several other things as well. Our issue, so once I realized what that ignition switch feeds, then I had the students go to the fuse block and we checked all of these other fuses. And guess what? None of them had power. So now all we had to do was go to the ignition switch. It wasn't really easy, but now that we have a much better educated guess on what the issue probably is, now we can get to the connector for the ignition switch, unplug it, and see if we're getting power out of the ignition switch in the run position. we did that. We were not. We were getting power into the ignition switch right here. So it would have been a good idea to check, this fuse as well. The ignition, what is that? Ignition B fuse, it looks like. It would have been a good idea to check that. If it checked out, then go to the ignition switch. But it turned out our ignition switch was bad. The electrical part of the ignition switch was bad. Y'all, I have seen this a handful of times in my years working for General Motors dealerships. I've seen the ignition switch cause the transmission not to get power, where it was defaulting to third gear. It'd take off in third gear, wouldn't shift. All kinds of really weird things an ignition switch will do. So we did replace the ignition switch. That fixed the issue. I hope this helped you with maybe diagnosing something other than an ignition switch. But I wanted to give you a real life scenario of something that I have come across, my students have come across. And I wish, if I could go back, I would have kept a log of all the vehicles that I had repaired and all the really weird problems that I encountered and how I diagnosed them and how I fixed them as a technician. But it's been about 20 years now since I was a tech. I spent 14 years as a tech, 14 years as a service manager, and now I've been teaching for almost 9 years. So it's been quite a while since I was a tech. So anyways, I wish I would have kept the log so I could give you some more examples of case studies. But I'm going to reach out to some of my dealership contacts and get them to give me some of the electrical issues that they've seen, the customer concern, the cause, and the correction. And I'll do some more of these case studies. Another thing that I'm thinking about doing is I've had some questions in chat about, for example, on my schematics video, like someone asked, how does the BCM play into the horns working? So I may do just a YouTube short on how what part the BCM plays in that. Okay. Anyways, just wanted to make a quick video of a case study. Thank you guys for your support. I appreciate it a ton as an instructor and someone who just genuinely loves people and loves to teach. I hope you gained some knowledge from this. Please give me some comments in chat. Tell me what you think. Good, bad, ugly, whatever. I'll take it. And until next time, take care of yourself. And remember, if I can do this, anyone can do it. So just take your time, come up with a methodical process, and you can do it. And I will see you guys soon. Take care. God bless.